Hello, I am Vivek Nagle. Today I am presenting my topics binary and counting semaphores, wait and signal operations. So before discuss on semaphores, we need to understand some terminologies such as race condition. When two processes to access the same resources at the same time, then race condition occur. So semaphores. To avoid race condition, concept of semaphores comes in the picture. The semaphore is simply a variable that is non-negative and shared between threads. Semaphore is a counter whose value is either incremented or decremented. We can also say that semaphore is a thread that provides some time to process it, that work simultaneously and want the same resources at the same time. And we know that a thread is a small unit of execution. Due to thread, same resources are shared to the processes that want it at the same time. Due to semaphore, race condition is avoided and process synchronization provided by the semaphores. Due to race condition, there may be a loss of data, deadlock, etc. problems occur. Semaphores support mutual exclusion. Semaphores is used in critical section problem. So first we'll discuss what is critical section. The critical section is a code of segment where the shared variable can be accessed. Only one process can execute in its critical section at a time. In diagrams we can see that there is a critical section. In critical section there may be a more of resources that is acted by processes. But we discuss in the semaphores, only one process at a time at a same time can access only one resources. So the critical section we can say the critical section has the number of resources in which process enter, access resource and execute its task that it wants. So next we discuss characteristics of semaphores. Characteristics of semaphore. This is a mechanism that can be used to provide a synchronization of tasks. It is a low-level synchronization mechanism. प्रोसेस के synchronization provide करने के लिए हम semaphores का use करते हैं. Semaphores will always hold a non-negative integer variable. Semaphores एक counter होता है जो कि non-negative integer value को होल्ड करता है जिसकी वैल्यू या तो इंक्रीमेंट होगी या डिक्रीमेंट होगी डिपेंडिंग अपॉन द प्रोसेस critical value. Semaphores can be implemented using test operation and interrupt, which should be executed using file descriptor. Can permit multiple processes into the critical section at once if desirable. As we discussed, semaphores support mutual exclusion, which means two multiple processes can work simultaneously and access resources at the same time. Next, we discuss types of semaphores. Semaphores are of two types: binary semaphores and counting semaphores. In binary semaphores, the value of semaphore integer variables is either 0 or 1. When process want to enter in critical section and the value of semaphore is 0, it does not enter in a critical section. When value is 1, it enter in critical section and executes its task by accessing resources. Here we said that here we can see that there is a shared resource in the critical section. Here we can just see that shared resources it is in critical section. So further two processes comes in comes to execute its task in critical section. If the initial value of a binary semaphore is 1, this only one process comes in the critical section and executes its task. Next types of a semaphore is counting semaphores. So next is counting semaphore. Counting semaphore has two operations, down and up. So what is counting semaphores? Counting semaphores has two operations, down and up sections. For example, in the diagram, we can say that we can see that there are four resources in critical section, and process want to access that resource. And we know that only one process can access one resource at a time. To access that resource, process enter in a down section. When process enter in a down section, integers the value of critical section decremented by one. So if the value of critical section is 4, after decrementing when process enter in down section, the value of critical section becomes 3, and one resources is released for one process at a time. So if this value is negative, process cannot enter in critical section. Critical. One resource and executes when the process enters in critical section. Access one resource and execute its task. After execution, its task it exits from the off section. Means this section, off section. After existing process, release its resource and value of critical section incremented by 1. Means when process enter the critical section value decremented by 1, and when process executes its task the value of critical section incremented by 1 when the process releases resources. So in the diagram we can say that there are three threads A, B and C, and value of one process is 1 0. Then decrement, so value becomes minus 1 0. Then again decrement, value becomes minus 1. Then again decrement, value becomes minus 2 and 1. After executing, the value becomes 0. So next we see what is the difference between binary and counting semaphores after discussing binary semaphore and counting semaphore. Counting semaphore is a semaphore whose integer value range over 0 and 1. Means binary semaphore में इंटीजर्स वैल्यू सेमाफोर की ओनली 0 और 1 होती है. काउंटिंग सेमाफोर में वो वैल्यू कुछ भी माइनस इन्फिनिटी से इन्फिनिटी तक अप्लाई करती है. जीरो माइनस सेमाफोर में जीरो का मतलब है कि प्रोसेस और जो है वो क्रिटिकल सेक्शन में एक्सेस हो सकता है, जबकि जो अदर प्रोसेस रहेगी वो वेटिंग कंडीशन में होगी अगर क्रिटिकल सेक्शन जीरो है तो. वन रिप्रेजेंट द क्रिटिकल सेक्शन इज फ्री. In counting semaphore, the value can range from 0 to n, where n is the number of process or thread that has to enter the critical section. बाइनरी सीमाफोर्स में म्यूचुअल एक्सक्लूजन हो सकता है. हमने म्यूचुअल एक्सक्लूजन का मतलब होता है दो प्रोसेस एट द सेम टाइम एंटर कर सकती है क्रिटिकल सेक्शन में, और वन यूजिंग थ्रेड only one resource is shared to its processes. In counting semaphores, it does not support mutual exclusions, and since more than one process or thread can enter the critical section at a time. Then we discuss how semaphores work. So we discuss how semaphores work. Suppose in diagram we can see that there is a critical section which has four resources. Two processes simultaneously want to enter in critical section to execute its task. For example, the process P1 and want to enter in a critical section. If the critical section value is 4, then the value if there are resources in critical section and the process wanted to accept that, the process first enter in critical process enters in critical section by taking the value. If the value of process P1 is 0, it does not enter in a critical section. If the value is 1, it enter in a critical section, accept the resource that it wants and execute its task. For example, if P1 and P2 both processes want to enter in a critical section, Then further two operations performed in semaphores. Wait operation, signal operation. Wait operations always decrement the value of integer the value of semaphore. These operations decrement the value of its arguments. Here the body of wait code. Here we pass as an argument s as an integer the value of semaphore. Then write while loops when a is less than equal to 0, and we know that the wait while loop will continue until it falls to the conditions. The next is signal operation. Signal operations. Signal operations always increment the value of binary semaphore. Always increment the value of semaphores. Then next we discuss what is the advantages of semaphores. With the help of semaphores, there is a flexible management of resources. Semaphores की मदद से हम resources को manage कर सकते हैं क्योंकि semaphores में only one at a time to one process को resource execute होता है तो इससे deadlock की condition avoid होती है. Semaphores are machine independent and they should be run in the machine independent code of the microkernel. Semaphores do not allow multiple processes to enter in the critical section. And so semaphores follow the mutual exclusion principle strictly, and these are much more efficient than some other methods of synchronization. So means using semaphores we can provide synchronization of processes. There is no wastage of resources in the semaphore because of busy waiting in a semaphore. As processor time is not wasted unnecessarily to check if any conditions. Means there is no wastage of resources using semaphores because semaphores use thread. And we know that in multi-programming, multitasking processors, thread is used for to allocate the resources to the allocate the CPU to the processor and resources to the processor. Then, what is the disadvantages of semaphores? One of the biggest limitations of semaphores may lead to priority inversions. For example, if a low priority process access the critical section first, then high priority process may access the critical. To avoid deadlock in the semaphore, the wait and signal operations are required to be executed in the correct order. Their use is not enforced, but it may convention only. Thanks for watching. Thank you.